User interface techniques. We talked last lecture about some of the things that you might maybe need to build in a typical application. We covered messaging and error handling in the last lecture, and we showed you responsiveness, so I won't recap those too much now. But in the extended demo, we've added some tab functionality, some modality and overlay functionality, i.e. pop-ups. There's some basic navigation in there at the moment, but I'll probably plan to expand that later, so keep an eye on the source in GitHub. And I'll talk a bit about using icons in a bit more detail, and about some of the other things like data paging. So this is taken from the sample application I'm going to show you, and we have some tabs here. And the way you deal with tabs in a DSP application is really you have everything in one page, and you just use CSS to hide the pages that you're not interested, the tabs you're not interested in. In CSS, in style terms, that's display none or display block or inline. So you just have a div around each area, an HTML element, and you're just literally hiding the ones you don't want. Now, a lot of the CSS frameworks like Bootstrap automatically provide you with various CSS classes to do this for you, and some JavaScript to do it. In this example, we're loading a basic page that's contained in its own DSP. All we've done is within the DSP, we've added a DSP container within the tab, and the DSP container loads the page into it, so you can easily switch between them. But the front-end JavaScript and CSS is completely unaware of that, really. So in order to get that implementation, I didn't really have to write any code, as you'll see later. It's mostly all done with just HTML and CSS. The other thing that you probably want to do is get overlays or modality. I liken this to a lightbox effect, which is what web developers call, if you ever look at a photo album and you click on a photo and it grays out the background and your current photo you've clicked on gets displayed, that's what they call a lightbox effect. And what's actually happening here is just a bit of CSS trickery, really. The form that you're displaying is actually just appearing at the end of the page, and via CSS we're just moving it to the position we want, and we're changing its Z index, which is basically the depth. Is it in front or behind of other things, and the color and the opacity, so that it looks like it's on top of it and the back is grayed out. Now, if you did that yourself, that would take you a bit of effort learning the CSS that you need, writing JavaScript methods to do it for you. Most frameworks will provide you something like a .modal and a .hide method, and that you apply just to the div that surrounds it to show or hide them. Again, that makes it very easy. So all I've done is taken advantage of that and given you a component which encapsulates that functionality. You'll see this at the sample a little bit later. So how did I build that? Fairly straightforward, really. I created a DSP to handle modal display. I didn't actually have to do that. I could have loaded it straight into a container on the main form, but what I wanted to do was add some extra functionality, things like a title, messages and so on, buttons, and a callback, so that if you actually click on a button, it would automatically call some supplied code. And I thought you'll want to do that again and again, so there's no point in me implementing this on every form that I actually build. I'll just do a container to do it. So that's what I've done. There's a DSP called boot modal in there that does this, and you'll see this soon. The main page just has a container that loads that in, and then when we want to use it in another DSP, so in my example here I'll show you the sample modal form, I just activate the show method on that DSP, give it the title, give it the message, tell it what instance of a component that I've instantiated I want to display in there, give it some buttons that I want to display, yes or no, optionally, and optionally supply a callback. So in this case, $instance_name is the component I'm running, and I've written a method called confirm callback, and once they click yes or no, it will actually call that method and tell them what happened. Again, returning 0 because on it we always want to give a success status. Data paging, for those of you used to building Uniface desktop applications, you'll know that we have a stepped hit list facility whereby if I retrieve something that might match 1,000 occurrences, we might only get the first 10 back. As I move to the 11th occurrence, we'll get the next step, maybe the next 10, for example. Now, in a web application, that hit list will be automatically completed, i.e. we might get all 1,000 occurrences. So you want to use a different technique to do this. Now that's fine. There's a sample on unifaceinfo.com which shows this technique in action. Not quite as pretty as the one I've shown here, which I will make available in due course. But all we're doing is we are using the DBMS driver functionality, which for pretty much every database now, with just a few exceptions, supports the idea of an offset and a max hit. So the first time we read a max hits of 10 records. Next page we read with an offset of 11, let's say if there's 10 per page, max hits 10 again, 21, 31, etc. So that's all we're doing. These are just options for the read command, and you just tell it what we do, and we're just tracking where we are in the page. And that's pretty much it. The sample that I'm showing here is slightly more sophisticated than the one you can find in Uniface Info at the moment, in that, again, all I've done is I've put the content of the table inside its own container and put all of the controls in a generic DSP that handles the retrieving and the clearing and the paging, so you don't have to write it on every page you build. So the concept's fairly straightforward. Okay, so moving on to using icon fonts. Again, I talked about this in the last lecture, but the idea is that by loading some CSS which defines some fonts, you've got some nice looking images that are resizable, can be CSS classed, so if I want to change the colors I don't need to build new images, for example, and look consistent and are quite nice and perform well. Because you're not loading loads of images over the network. Sure, they're cached in the browsers, but still, the less you load, the better. So in this example, we're loading in those resources in the header. Remember that in a DSP, the header is actually used on the main page and then ignored in contained components. If you want to actually inject them dynamically, you can. You just use $webinfo CSS. In a similar way, you can use $webinfo JavaScript to inject JavaScript if you want. Now, the HTML shown here below is straight out of the Font Awesome examples. They use an I tag. I guess semantically that might be better as a span or a button, but they just use I for brevity. It's fine. You can use whatever you want. The key points here to note are that we're using FA, says we're using Font Awesome. FA Home, it would be a home icon, i.e. a little picture of a house. And the FW is fixed width, so if we use those on all the icons, we get a consistent width, irrespective of the fonts we're using. And the key point to note, the other key point to note here is that we are using a Uniface ID. So by doing that, we've actually just attach some code to it. Maybe we've got a extended trigger with an on-click event, for example, or a using an attributes only field in this example. If it was a Uniface generated button, it would actually be an input type equals button, so it's slightly different. And in that case, you'd probably use the detail trigger rather than the attributes only, and would you actually use the button widget. Now, many of you who build desktop applications with Uniface now will be using some of the power of Uniface modeling to build yourself maybe a standard entity where you actually have fields for all your common buttons, retrieve, clear, store, etc. You build them once, you just paint them on your forms, and you don't have to think about the implementation other than maybe change the code as to what it does when it's pressed. Now, if you want those buttons to display the icons, because it's an input type equals button, you need to emit the Unicode character for that icon. Now, if you go to, say, the Font Awesome site, or it's similar for things like glyph icons or other libraries, you'll see that it lists you the Unicode characters that are used. There's a cheat sheet page that shows you for each icon. Here on the retrieve, we can see the browse icon. And what I do to make that a little bit easier to understand, I add the FA class on all my inputs. I have a standard list of defines. This is the pre-compiler in Uniface. Look it up if you're not familiar with it. And I actually define what that Unicode character is. And then in my format trigger, I've got a test here, again using the pre-compiler, to say if I'm in a DSP, so this won't get compiled in to other non-DSP pages if you're sharing logic, for example, with a desktop application. And we're modifying the format to add that icon in before the word retrieve. Now, of course, if you're multilingual, no problem, you can use $text to get that text there. But this way is just the way I do it. There's other ways of doing it, but I find this works quite nicely because you can then actually have conceptual names for the things that mean something to you. And again, I'm not rebuilding this every time I paint a retrieve button on a form now. I can just paint my modeled entity, drag it in, I'm done. So this is something perhaps to refer to later when you come to do it. So these slides will be available on SlideShare. So nearly done with the presentation part. Considerations to be aware of. I touched on security earlier, but remember with any web application, anything that's shown to the user, sent to a browser, can be modified if you know what you're doing. Now, you don't need to normally worry about the URL in a DSP application because we don't update it. It's a single page application, so the URL does not change as you move between pages because we're loading pages into containers. However, it is possible using things like the HTML5 history API to actually make that change as you do it. And that might give some benefits to the user, but you just need to be aware if you do it that you are then exposing that to modification and thereby introducing a possible security risk. You can actually work around that by including hashes in there, for example, and doing tamper checks, but it's just something else to think about. In the same way, anything in cookies or hidden fields can be modified by the user. So I mention this now because it's something to consider before you start building your code. I find it better to put things that are sensitive in things like session state. You will see in the example application, and again the source code is available on GitHub. You can use things like $webinfo session commands, and you can actually use the session object and store things there in Tomcat, for example, or whatever your servlet engine is of choice. And that prevents the users actually modifying it, and it also means that once the session's gone, that storage is gone, so you don't have to clean things out of the database. But there's lots of ways you can do it. As I said, always validate on the server as well if it's sensitive, and if you use a secure protocol to connect, HTTPS, SSL, that will reduce the risk of man-in-the-middle attacks. I mentioned also that if you set the server secret, which is configured by default in a normal Uniface installation, Uniface will create hashes of any non-editable fields and check and give you errors if they've been modified by an end user. The other things you'll want to think about, for example, is we are loading containers. We're using containers to load pages into. You could, if you know the names, go and actually request them directly. So you want to actually do things like check the user is authenticated when those pages are loaded. You could do that, for example, in the get state triggers or set state triggers, or on your button presses, for example. If you don't do that, then there is a risk that people could get to a page that otherwise they wouldn't be able to get to. So just think about people trying to circumvent your navigation. And of course, use public web for browser-activated operations. If you don't want people to activate the code directly, remove that or put partner web. Now, there's a lot more to security, and I think we will be doing some more lectures on that topic in the future. But if you want to see more, have a look in the help. There's a very big help topic again on web security guidelines. If you don't have a Uniface installation in front of you, you can go to Uniface Info and download the documentation. It's all there as well. So, other things to think about: performance. Some of these are fairly obvious. If you move some of your logic to the browser using the JavaScript API, you're reducing the amount of server code, so you're splitting the functionality. and that can help your performance. The other thing to be aware of is that Uniface stores your data in the DOM objects in your browser and synchronizes it, as we discussed before, and that saves you having to persist it and reload it every time when you go between your pages, because remember, the web is stateless. However, things like component variables will still be lost, so you kind of want to think about that and do we cache things. Now, that data cached in the browser, if you're opening lots of forms and then hiding them, it can build up over time. So it may be that you want to consider about whether you have attach and detach operations. These are automatically fired when you assign a DSP to a container and when you deassign them. So for example, in the detach, you could actually clear your data, and then when they attach, retrieve your data. It's a trade-off that you might want to consider. If people generally want to go away and come back again, then you probably won't do that. From a network viewpoint, just reduce the amount of data that is actually sent over the network, and various simple things you can do to help with that. If in your DSPs you only paint the user interface entities and you put your business logic in services, that separation of concerns that's general good practice, then you will not be synchronizing those entities used for the business logic every time you click a button or do a page. So that is only then synchronizing the painted fields and entities on the form, which is probably a better idea. If you use DSP containers to implement components, so you saw in the last lecture that I put the alert functionality, that messaging, in its own little container, then we're controlling the scope even more. So we're actually only synchronizing that what it needs to do that functionality and not displaying a load of extra information. And I showed you scoping earlier about you can tell Uniface you want to send data in and send data back. Imagine you had a display page that showed you some statistics, maybe a dashboard, and you don't actually need the information on the screen to actually redo that. You've just got a button saying update. Then you could actually remove the input scope and just say output scope only. And then again, you're reducing the data that's actually sent to synchronize. We're only sending the data back, not sending it to the server. So there's various things you can do to improve things there. Finally, on the server side, think about state management. It may be that saving your state, things like your component variables, only use a fraction of time for one thing. But let's say you've got a page with 20 tabs and each one is loaded and cleared, then in aggregate that can add up a little bit. So if you reduce the amount you save in state as much as possible, that will aid your performance, I find. And other than that, a general good technique for web applications is to cache data that you've built. So if, for example, you're building drop-down lists, you may want to actually cache that built drop-down list rather than reading it from the database every time. There's even a sample on Uniface Info of storing that in an external cache server like CouchDB, but you can even use things like global variables if you know they're just used to cache things or talk to external servers. But it's generally a good technique to do this and prevent a lot of rebuilding of everything every time it's used, especially for static data. So, the usual list of resources here: the help, training online and classroom, Uniface Infos, where we encourage you to talk about these things. This lecture and previous ones will be on YouTube channel, and you can see a lot of our sample code, including the code for this WebStart project I'm about to show you, on GitHub. So I'm going to finish you by showing you a little demonstration of that.